let me share a screen. All right. I'm putting this up on the screen again to remind you that on this coming Saturday, the test is at 12:30. You're going to have 1 hour, 45 minutes, and then 15 minutes to submit. This is just because I really don't want anybody to lose 15% of your points because you forgot. Okay, are there any questions before we start lecture today? Today we're going to do objects. All right, so let's start the lecture, and you can ask the question if you come up with any at the end. So far, the data types that you were using in Python were those that somebody else made. Okay, so this includes, for example, integers. So we were creating integers by doing something like x is equal to 10. So the right-hand side in this expression creates an object of type int. So you have seen you were using the data type int. Then when you would do something like this, you were creating an object of type float. What else have we seen? When you do something like this, you were creating an object of type str for string. What other data types did we see? Lists, 2, 7, minus 3.3, that were lists. Then tuples, immutable lists. So I don't know, true, 1, 7. We've seen tuples. So last class we have seen sets. We have seen dictionaries. What else? What other data types have we used that somebody else designed for us?
Boolean.
Boolean, thank you. True or false, this creates a Boolean type. Anything else?
Complex numbers.
That's true, complex numbers, but that was for those.
The turtle graphic.
That's right, turtle graphics actually. So for those who there is in Python a special data type to handle complex numbers, but in one of your assignments you were actually asked not to use that. But the one data type that was just mentioned, those of you, by the way, when you're not speaking, can you mute yourself because I hear some background noise? But one of the things that actually looks most like object because arguably a number 10 and numbers don't necessarily look to us as objects, although in Python all of those are objects. But the one that looks arguably the most like objects you have seen in your assignment number 1, which was a turtle object. So you were creating a turtle object, and that kind of created a point in the middle of the coordinate system of the screen that you can then move around. Okay, so another thing that we can see is an object of type turtle. So far in the class, you were limited to the data type that somebody else designed for you. And so these are examples of data types that we use. Due to some of these limitations, there were cases when it was kind of cumbersome and not totally intuitive to work with these given data types. And that gives us the motivation to design our own data type. So let's look at first and at some examples of when it wasn't necessarily the best to the most intuitive way to use the most intuitive way to represent data wasn't necessarily with the data type that are given to us easily in Python. So for example, one example could be the trivia quiz game that we made. Remember, all the data was stored in a 2D list where the elements of these 2D lists were were lists with 7 elements, where the first element of the list was an actual question. And then we had the answers. The second element was the first answer, the second answer, then we had the difficulty and so on. So if you wanted, so if we had this as questions, so all of those about 700 questions that we had were stored in a data type like this. And if you wanted to access a particular question, let's say at random, we pick a question in position I in this, from this list of about 700 questions, the way we had to handle, access the data that we need would be that this particular question, if I wanted to display question, I have to access a queue of 0. So an actual question that I want, I will be using something like this to access it. That was for a question. If I wanted the first answer available for that question, I would have to do something like this. That was for A1, answer 1, QI, I guess at position 5 was for difficulty, and so on, okay? So in this case, kind of, we are representing data about question, various data about question in this kind of list of length 7, and then we plot them all in another list. So it's kind of arguable. This doesn't look the most intuitive thing to access something that is a question, right? So wouldn't it be much nicer that we have a data type called question, right? So once I create a question, let's say I have a variable q for a given for one question, that I access an actual question by doing, let's say, q.question. That I access answer 1 by doing q.a1, answer 2 by doing q.a2, q.a3, q.a4, and then q.difficulty for difficulty. And finally, we have q.category or whatever. Oh yeah, there was a category as well. Like, was it food or was it entertainment and so on. So it would be much nicer if we actually had our own data type. Even if we're gonna, again, put them in the list, then at least your list then would have elements which are of type question. And so your list, each element of your list would then be object of type question. And in that case, you would be accessing individual data like this with a dot operator. Okay, so that could be our goal is actually to learn how to design our own data type. How do we actually do that? So one of the jobs of programmers, and not just programmers, of this computational problem solving, is not just how you solve a problem, it's also how do you organize the data, how you store the data. That's going to affect your solutions and complexity of the whole thing. So this is a big topic within this area. Okay, so let's start with the simplest example, because we just want to learn how do you design your own data type. All right. So what I want to do, for example, is let's say I want to design a program, and it has to, what I need to work with, the input is going to be a set of points in the plane. This appears in many applications. You can think of graphics, you can think of geographical information system, maps, and so on. In some form, you may be getting information representing a set of points in the plane. So let's say I'm talking about plane 2D. We are in 2D. All right. So let's say we are working with endpoints in the plane. So before we design our own data type, if this was, let's say, part of your homework, and I tell you open a file, and inside of the file you read off the data about the point set, probably the most common way to represent this before designing your own data type is to store these points. But before I tell you that, actually, we somehow appoint. When you're talking about points, you need to figure out what is it that determines a given point, right? So what determines the points in the plane? What pieces of data do you need to know such that you know what point we're talking about?
It's coordinates?
Yes, so one way is to do the coordinates. So if you're in the plane, The most common way to present the points is that you give me X coordinate and Y coordinates. So you have a coordinate system with the center of the coordinate system somewhere 0, 0, and you give me coordinate points of a point. So that's probably the most common way to represent it, but it's not the only way. Another way that uniquely determines a point in the plane is if you have a coordinate system. Somebody can tell you, oh, I'm giving you an angle with respect to an x-axis, angle alpha. That determines, if you just give me an angle, that's going to determine all the points on this half line. But if in addition you give me distance from the center of the coordinate system, if you give me these two pieces of data, an angle and then the distance from the coordinate system, that also uniquely determines the point. So your point can also be determined by an angle and distance from the coordinate system. That may depend on where your data is coming from or who your customer is and so on. Just to mention that even some of these things are not necessarily obvious how you would represent a point. You as a program may have a choice, or maybe the data is coming from somewhere else. Okay. So let's go back to this more common way to represent points. And if you need to represent a set of points, n points in the plane, common way to do this, if you didn't design your own data type, is to represent it as an n×2 matrix. Okay, where a first point is represented by a first row, a second point by the second row, n point by the nth row. And where in the first column represents an x coordinate and the next column represents a y coordinate. So you can say, oh, my first point has coordinates 3.5 and 7 and so on. So this is when you think of it as a matrix, but if you want to represent it in Python, we have seen that we would represent this as a 2D list. And where elements of these 2D lists are sublists of length 2, where what did I have here? The first point would have this coordinate, the next point would have 2 coordinates x and y, and so on. So we would have n points like this. So a list would have n elements, so n sublists of length 2. So if I want to access, so if this is my set of points, if I call this list P for the set of points, and I want to access a point in position I in this list, then P of I 0 would give me an x coordinate of the point. And if I want to access its y coordinate, I would use something like, not something, I would use exactly this. Okay, so although this is not terribly complicated, one can say this is still not the most natural way to represent a point. Wouldn't it be nicer that if I have a point, some point P, so I have a variable P referring to a point, that I just do P dot x to access the x coordinate of the point and P dot y to access the y coordinate of the point, okay? So if you want that, then you design your own data type. So if you're not happy with what's available to you in, let's say, built-ins and whatever modules you have at your disposal, you can choose design your own data type. So that's what we're going to do today. We're going to basically design, in our first lecture on objects, we're going to design the simplest data type that I can think of, and that is one representing a point. All right. So one way to think of it is that with the variable P, I associate 2 pieces of data. So each point should have an x coordinate and a y coordinate. So these are the pieces of data that I want points to have. Okay, so let's see how to do this in Python. Let me see if okay. So let's look at the turtle graphics, and I will explain why as the course progresses, because its syntax is most like what is going to be syntax of all your custom-made data types. All right, so let me open something that I did, I think, in a tutorial that I did right before the semester started, but you also did this for your homework, and you did this as for your, as you did in your assignment number 1, you also did it in the first lab, I believe. All right, so let's recall how we created a turtle. All right, so this is a piece of syntax that I would like you to pay attention to. So this is how you created a turtle. So you go on the right-hand side always, and the right-hand side typically produces some object. In this case, it produces an object of type turtle. All right, so let's understand what these two pieces, what these two things are. This first thing, turtle, just tells Python, as long as what you're using, it's not in built-ins and the most common modules that that are used in Python, such as strings and list, you typically have to import a module where whatever you're using is, and you have to tell Python where a particular function is. So this first thing before the dot is just telling Python where is this particular function turtle, okay? And then this is what I would like you to pay attention to. It's this part that I highlighted that actually creates a turtle object. Okay, so somebody designed a data type called exactly that, so the same name as this function. So somebody designed turtle, a data type called turtle, and the way to create a turtle is to call a function with exactly the same name. So it's a function call, you open parentheses, close parentheses, okay? And you have seen here, we created a different turtle. All right, and we can even see it here. If you do import turtle, you can even do it here. Alex is equal, let me copy this so I don't make spelling mistakes. All right, so you see that this created a turtle and put it in the center of the coordinate system of that, whatever of that window that is used in turtle graphics. So I'm gonna close this Python graphics window. Okay. All right, so what we would like to do is to do something similar, but for a point. So for example, let's try to mimic what we had. I want to create, I'm not going, so when you have a file, you've seen this before. So if you're running a program that is in your directory and you're running it from your directory, then you don't have to specify a path, Python just checks it. So I don't have to tell Python to look in my point class, what the name of the module is. I'm just gonna run a program where that point class will be. So I don't need this first part. So what I would like if I do, but remember, it's this part that creates a object. So what I would like to have objects of type point. And I would like, when I do something like this, that object of type point gets created. Okay, so let's figure out how to do that. So for example, when I do this, I would like, right now, nothing happens, name point is not defined, we get a crash. And then I would also like, when I do p.x, that I get an x coordinate of the point and p.y to get an y coordinate of the point. So let's figure out how to do this in Python. Okay, so let me open a file, new file. Why is this thing not turtle graphics? Why can't, doesn't let me kill it. Anyways, let me save this file. Okay, so here's how to do it. You decide, let's keep this in mind, what we want. I want this, all right? So you decide, okay, I want to design my data type. As usual, you have to tell Python, I'm about to design my own data type. Keyword for that is class. Okay, so you're telling Python what comes next is going to be my definition of a data type. After the word class, you need to tell Python how you're going to call your objects. Okay, so I want to call my object point. Okay, the convention is when you are naming classes, and class is just a description of what your objects are going to look like once you create them. When you're naming a class, when you're naming an object, the convention is that you capitalize the first letter. So convention is not to call them like this, the convention is to call them like this. So you capitalize the first letter the same way here. T was capitalized in turtle, okay? Then you put a colon, I believe this is colon, and then you start designing your data type. So basically, in some ways, it starts similarly off as, and when you're telling Python, I'm about to design my own function. You tell that to Python by putting keyword def, and then you give a name of your function. Okay, except that with function names in Python, the convention is to use all lowercase letters. You will see that these conventions are not the same across languages. Next semester, you're going to have Java in ITI 1121. You will see that the convention in Java, actually, when naming the function, is to capitalize the first letter in individual words, whereas in Python is lowercase letters separated by underscores. Okay, I was just using this to indicate this is a similar syntax. So with a class, you're telling Python that you're about to design your data type, and after that comes the name of the data type and then a colon. All right, so already this is something. What do I mean by that? Well, after the colon, Python expects some code. So if I try just to save this and compile it, it's going to complain because it expects something after this. But if I just put pass, literally mean do nothing, it's going to actually compile. In other words, it's going to run. So let's see what we got so far. Let's see what this gets us. So I want to do run. All right. So before, when we did this, before, it crashed. Okay, so let's try to repeat and see what happens. It didn't crash. Okay, so we actually managed to create an object of type point. Okay, it's actually kind of a useless object. It's an empty object. It doesn't have data. If we try to do p.x, it doesn't have anything. But the object itself, let me try to get this smaller. I don't know if this zoom little thing is only on the way for me or for all of you. Remember, type tells us what type of object variable p is referring to, and it's telling us that p is already referring to object of type point. Okay, so for example, if you do x is 10, remember it will tell us the variable x is referring to object of type int. So we already managed to create an object of type point, except that's kind of like an empty object, doesn't really have any data. Okay, so what is it that we want? Is that what is it we want is that we want data to we ask ourselves, what type of data do we want our object to have? And if we look at our plan for this, it was to have that each point should have two pieces of data, x and y coordinates. So actually, rather than creating an object like this, when we created an object like turtle, just like that, we didn't need to give any pieces of data. What Python did is created a turtle object and put it in the middle of the coordinate system. What we would like to do in our case for the points, what I would like is to have something like this, that I give this, when I'm creating an object of type point, I would like to give all the data that my object should have in the moment of construction, right? So I'm giving what I would like is that when I do something like this, 0.2, 3, I would like that an object of type point is created that has two pieces of data. The first data is an x coordinate, in this case 2, and the second piece of data, a value that you give me, becomes my y coordinate. So 2 becomes my x coordinate, 3 becomes my y coordinate. So what I would really like is actually to create a point like this. But now we actually have a crash because nobody defined what we should do with this 2 and 3. And I would like, when I do p point x, that it's 2, and p point y, that it becomes 3. Okay, so let's figure out how to do this in Python. So what you want to do is you want to say that my objects of type point should have two pieces of data. Whenever you have some data that you should store associated with an object, like in 2 and 3, of course, you need a variable for those two data. So pieces of data. So I would like that each object has two variables, variable X and variable Y associated with that object. Okay, so here's how you would do it in other programming languages. So you would want to have each object of type point, you have a variable X and variable Y. So what type of data, what type of information do we want stored in these variables X and Y? Well, we want them just to be numbers, right? I wanted it to be an integer and a float. So in that case, in other languages, you would do this. Float X, float Y. You would do it like this. You would just tell Python objects of point X should have two pieces of data, objects of class point should have two pieces of data, two variables, X and Y, that should store floats. Okay. And this makes sense in other languages because actually what you're doing here, you're declaring a type. You are saying that create a variable X and it should be of type float. Create a variable Y, it should be of type float. But this is not the way you do this in Python. Python, you don't declare the type. Basically, variables don't have type because you can assign to each variable anything you like. The way, remember, the way you're creating variables in Python is by assigning something to them. So for that reason, actually, if you want your object to have specific data types, then you should do this by designing the following function. Okay, so let me show you how to do it. It's not the most obvious piece of, let's say, syntax, so it's kind of language technicality, but once you understand what it is, it's actually very easy. So it just takes understanding what exactly are we doing. So the way, if you want this to happen, what you do in Python, you inside of your class function, you need to design a function. Okay, and we know how to design a function. We start with the word def. So after def, as usual, you need to put a function name, except that this time you don't get to choose the function name. Okay, you have to use a special function name that is used for creating objects. The name of that function, again, not necessarily very intuitive, is underscore underscore init underscore underscore. So you have to use that function name. Okay, and then you proceed for the most part as with designing of any function. So here's what you do next. So what is going to happen when you call this? This point here, Python is going to go to a point class, and instead of looking for a function called point, it's going to look for this function, underscore underscore init, and it's going to run it. So then you ask yourself, okay, if it's going to run this function, I need to give it two pieces of data. And remember, whenever we design a question, I say, okay, how many parameters should my function have? Or rather, how many variables should I have in a function header? You determine that by how many pieces of data the user is going to give me. So in this case, I need two pieces of data. So I need two parameters. Let me give them reasonable, meaningful names. X coord for the X coordinate and Y coord for the Y coordinate. Okay, so that's so these are the two parameters that will capture this value 2 and this value 3 that the user sends when they're creating an object. Okay, so although what this looks like a function call that in essence is calling init, has only two values, this function actually has 3 parameters. So in fact, you have to put as a first parameter, you have to add another parameter and it has to go as a first one. Okay, so what is that parameter? Just like any other variable, any other parameter, you can name it yourself, but convention is to call it self. Okay, so, all right. I'm going to explain what it is. So self, we're going to spend more time, but for now, let me just say that self is an object that you just are about to create. So for example, if you do this line, self would be P, because what you want to do next, you want to create a variable P.x and P.y. So to do this, I need access to a variable P. So, but this I did I do normally after I code this. So variable self is a variable that gives you access to the object that just gets created, okay? So we go, let's now code the body of the function. And once we run this, it's going to be more clear what I'm talking about. Okay, so self is the object. Think of it as P. And I want each object of type point to have its own X coordinate and its own Y coordinate. The way you do this, you use a variable name that gives you access to the object. In our case, is self. And then you use a dot operator, and then you give a variable name, so a piece of data that your object should have. So I want my object to have a variable called X. So if we go back to my drawing here, so this is what I want. I want my variable to have, each object to have variable called X and a variable called Y. Okay, so in that case, this creates a variable X that belongs to object self. And what do I assign to this variable X? Well, whatever user gave me. So whatever user gave me is stored in a parameter X chord. So in this particular case, what will be stored there is a 2. So we get X, self.x is 2. We do the same for the Y coordinates. So my object self, the object that just get created, should have a variable Y. And remember, in Python, you create a variable by assigning something to it. So what do we assign to it? Whatever the user sent us for Y chord, and that's 3. So this is the same as doing self dot Y is equal to 3. So that creates a variable Y that belongs to self and object for the object that is just created. And in our example, it would be 3. Okay, so we coded it. So let's first run this to see that it does what I want, and then we're going to go through this slowly to understand what exactly happens, okay, when you call this function to create the object. Okay, so let's run this. So previously, when we did this, we had a crash, but right now we don't. It didn't crash, and when I did do p.x, it's a 2, and p.y is a 3. So it worked. So let's see actually what exactly happens when and what is this magic function call. All right. So let's understand what exactly happens. So in Python, when you want to create an object, what you have to do is, if the name of your class is point, you have to call a function with exactly the same name. Although when you look here, there is no function called with exactly name point. So what you do, you call a function with the name that is equal to the name of the class. Okay, so that's what we were doing. And then you give it pieces of data that it has, and hopefully you coded it so it works. Okay, so what happens when you call this? So let's understand what happens when we do this. So oh, that's not what I want to save. All right, so here's what I want to explain. So when calling point 2, 3 does the following. Does the following steps. Okay, so the steps are: 1, first object of type, and then the name of the class of that type, of type point, gets created. Okay. Second, an address of that object, right now still empty object, is generated, produced, if you like. And third, if there is init function. So third, what Python does, it goes to the class with that name and looks for init function. So if there is init function, it runs it. And, not and, by passing the address of the object created into to self. Okay, so let's go through all of these 3 steps. Okay, so first thing that happens is that when you have a class, when you call a function with a name, so here's what we did before. When you call, whenever Python finds a function and it has a class with exactly the same name, it does exactly these 3 steps. So first of all, it creates an object of type point. We have seen that already when we didn't have any code inside of the class. So step 1 was already working without any code. It produces an address of that object. An address of that object that is just produced is created. Okay, so and then it runs an init function. So when we didn't even have, if the init function is there, when we didn't even have an init function, when we just had this and did a p is equal point, that's why it didn't crash. It just did step 1, it just did step 2, then step 2, and then it looked for init function is not there, and then it's done. So let's see what actually happened exactly. So it calls this, when it calls this function, it finds the class with the same name, it produces an object of type point, it creates an address, and that address, if you like, is returned, and that address, then you see, is assigned to P. So P was assigned an address of an object of type point. But that object didn't have any data, but that's what happened. Step 1 and step 2 worked, and there was no init function, and we were done. Okay, but now that we have an init function, after step 1 and step 2 are done, Python finds init function. Okay, so inside of an init function, remember there is a special parameter called self. What Python does with it, it stores in self an address of an object that it just created, because you need access to that object. So in self, it stores the address that it just created in 2. So self gives you an address, gives you an access to the object that is just created. So self is the object that is created, and then the rest of the function is like every usual function call. So the function call that we have is this, so 2.3. So self is an address, then Python takes the next parameter, looks for the next argument. This is 2, so 2 is assigned to X coord, takes the next parameter, looks for the next value, it's 3, so 3 is assigned, so 3 is assigned to Y coord, looks for the next parameter, no more parameter, we are done. So what's stored in these 3 parameters, self stores the address of the object just created, X coordinate and Y coordinates, is like any other function call, it stores the values that you sent in the function call. So then it's done with that part. So this part is done. Then it just execute the body of the function like anything else. Basically, this value X coord is 2, is assigned to variable X that belongs to object self. Self is that object that we just created. So this creates a variable X that belongs to self. This creates variable Y to belong to self. The values sent to these variables are 2 to X and 3 to Y. Okay, so what I want to do next, actually, to solidify what I just explained to you, let's look at this in Python Visualizer. I really hope you're using it because it's a super useful tool to understand many things about languages. So let's do this. So I'm here in Python Visualizer. So I'm going to first create, just like function definition, you have function definition and any custom-made data types, you put them at the beginning, and then you can use them, let's say, in your main or in other functions. Okay, so somewhere here, let's say in the main, I'm going to create a point. Okay, so in fact, I'm going to create 2 points, just so it's clear that we are, so how this works. So let's say this point is 3.51.4. Okay. Okay, so let's visualize the execution and understand exactly and see exactly what's happening. That when we are calling this, special function, indeed init function runs. By the way, this special function, the function that has exactly the same name as the name of the class, it's called the constructor. Okay, so this function is called the constructor. In fact, init, because it calls init function is a constructor of the class. Okay, so let's visualize execution. So as always, Python starts where it finds the first line of code lined up with the leftmost edge. And what it does here, just like with def, it just learns the class of type point exists and makes a note for itself that there is a class of type point. But nobody yet called the constructor of this class. Nobody yet called this. So this is a dead call until somebody calls the constructor of that class. So somebody is trying to use that class. So therefore, Python, after learning that a class of type point exists, it moves to the next line of the code, which in this case is line 9. So let's see this. Python learns that there is object, that there is a class of type point. It makes a note for itself. In fact, it makes a note of the fact that point class actually has an init function. Okay, so then we go to the next line. It's line 9. As always, you have an assignment operator. You go to the next, to the right-hand side of assignment operator, and there you have a call to a constructor. There you have a call to a function that has exactly the same name as this class. So in that case, what did we say Python does? Well, first of all, it's going to now run this code. This is not anymore that code. So what is it going to do? Is going to create an empty object of type point. It's going to remember its address. It's going to basically look for init function. It knows it's there. It made a point. So it's going to start running that init function. So you're going to see main is going to pose, and just like any other functions, this init function is going to start running, but the address of object self, address of the object that was just created will be assigned to self. So let's see that that's exactly what happens now. Init function starts running. Before that, an empty point or just a location of memory is allocated for the object. Its address is stored in self. So what do we have next? Value 2 was assigned to parameter xchord, so that function init has its own variable xchord whose value is 2. Value 3 is sent to ychord, so that local variable is created. So that's what happens after line 3, the moment you call constructor. Okay, let's execute the rest. So now this line is about to be executed. See right now on the right-hand side, so on the heap, right? All of these objects, they live on a pile, they live on a heap. That's where they get created. So you're going to see now, instead of an object that doesn't have anything, this is going to assign to that object a variable x. Okay, so let's do next. And variable x now belongs to object self, and it's assigned whatever xchord is, and xchord is 2. We go to the next line. You will see now that this object self gets a variable y, and what is assigned to that is whatever is in ychord, and that's a 3. So look now on the heap, we created an object. That object itself. So these are not variables that belong to functions. These are variables that belong to object. They're called instance variable. They belong to an instance of a class. So x. So we have an object. It has 2 variables, x, y. It has 2 instance variables. They are value 2 and 3. So just like any other function, this function init was running, and now it comes to an end. There is no return type. Okay, function returns nothing. So when it comes to its end, it terminates. But please pay attention now that actually it's as if this init function, but it's hidden from you. It's as if it returns the address. So kind of silently, what happens is that the address actually of this object here that is created this address is now stored in a variable to the left. So when I press next, as usual, the function will terminate, but the variable P will be created and it will be pointing to this object that we just created. So that's what happens there. Okay, so we created an object of type point with two pieces of data, x is 2, y is 3, and variable P stores an address of that object. By the way, all the objects are mutable. Your custom-made objects, by the way, are mutable types. So they are behaving like lists. They are behaving like sets and dictionaries. So these are the mutable types that we have seen so far, the types that are designed by Python, but all your custom-made data types are also mutable. Therefore, they're all, you have to imagine them all living on the heap. So they're on the right-hand side on the heap, and what's stored in a variable is always an address. So you have to work with that. All right, so let's come to the next line. The Python goes to the right-hand side. It finds a call to a function called point. It's the name is the same name as the class. So therefore, it does these exact same steps again. It's going to create an empty object, so a new object of type point, and run a function in it. So you see here, new object of type point is created. Its address is stored in a self, so init function, so main is pausing, new init, well, a new instance of init function is running. What's stored in self is an address of this new object. What is passed to X chord and Y chord are, of course, values in this function call. So X chord is now 3.5, Y chord is 4. And now that we have that, the rest of the lines can be executed. So self.x creates a variable x that belongs to this object. So you're going to see over here, so completely different object. This object is going to get a variable x to which x chord 3.5 is assigned. So this object now, after this line is executed, gets variable y to which y chord, which is 4, gets assigned. So we have a new point, a new object. Its address is over here. So we are at the end of this init function, and just like before, the init function is going to terminate, and the address of this object that is just created is going to get stored in Q. Okay, so we do next, and the object of the second object is stored in Q. Okay, so I hope that what you see now in Visualizer matches the explanation of what we have for what init function does. Okay, so let me go back and let's see. Yes, Matthew.
I'm not sure if I got what you meant correctly, but you said that behind the scenes, Python is returning the address stored on self, right?
Yes, it stores it in P. Some way it passes it to P, right? It was stored in self, but in some way, that function call, you see what happens here, this function call, the address that was stored in self is now going to be stored in P.
Yeah, so what happens if I just put return self below self.y?
That's not a syntax, so we shouldn't be inventing it, but maybe it's not going to break it.
Okay.
We can do it. There is no reason not to try. You can do a return self. And let's see, I don't see a reason why that shouldn't work, but who knows, maybe they're preventing you from some reason. So let's see, this should return none. It doesn't, it forces you to use specific things, it looks like. Okay, oh, save. Oh, no, sorry, that was something else that I was trying to save. Okay, Otman.
I have two questions about the self thing. First, self is not highlighted in any color, so does it mean you can use anything instead of self?
As I already said, it doesn't have, you can call it blah, but then you have to go here blah, and it's just a variable name, but convention is to call it self.
Okay, and so if you can't really do the init function without giving something like self, because the first argument of it is always going to be that, right?
Yes, the first argument, you need it. So if I remove this, Python is going to store the address of an object in Xcord. So it's going to store the address of the object in the first parameter of init function.
And if you put xcord dot ycord, it will give the y coordinate. If you don't have self in it.
Right. That's right. If you do right. So, I mean, I don't want to confuse everybody, but what Python would do if you do this, it always looks for the first parameter in init function and stores address in there.
Okay, thank you.
No problem. Ala.
Prof, when you said that like objects can, classes are immutable, just like lists and sets. Does it mean that they can be modified?
Yes, they're all. Yes, so we can do this already. By the way, we have this point. I can do p.x is equal to 100. Oh, I didn't create it yet. Let's say. All right. So let's run it, and I create a point. Name slef. Oh, here I'm misspelling things. Okay, so now p.x is this, but you can do p.x is equal to 100, and now p.x is 100. They're all mutable. Custom-made objects are all mutable.
I see. Thank you.
Okay, so that's how you create your own data type. This is the main thing, is basically this init function. I'm going to show you some other things until the end of the class, but what I wanted to mention first is, again, that when you're creating an object, if you look at the syntax, what you're doing is you're calling a special function that the name you're using is kind of user-friendly. You're going to use a name which is equal to the name of the class, but the Python is running this init function, which this init function has a special name. It's called the constructor. And and since this call is calling the constructor, this is constructor itself. So this here is a constructor. Okay, because it constructs an obvious, at least where the name is coming from, unlike mutable and unmutable. Okay, in this case, this is a constructor. So if you remember how we were creating integers, so let's compare this to a syntax of creating an integer and understand what happens. This thing here creates an object of type point and stores its address in variable p. This thing here creates an object of type int and stores its address in variable x. I hope you see that this is all the same. Okay. But this one here, we are not creating by calling any constructor. Okay. So what did we say? How do you call a constructor? You use the name of the class. So what is the name of this class? Type x. So x is pointing to an object of type int, and p is pointing to an object of type point. So when we were creating, let me repeat all of this because I want to compare them. So somehow when we were comparing in 10, when I was creating objects of type int, I wasn't calling int constructor, or was I? You are de facto calling the constructor, but it's hidden from you because that would be horrible syntax. Okay, but in fact that syntax works. You can do x is equal int 10. That creates an object of type 10, object of type int whose value is 10. Okay, so you are de facto calling the constructor, but this would look so bad. Imagine you want to add two numbers like 4 and 4 plus 10, and if for that you have to do int, let me first create 4 and let me then create 10 and let me then add them. Okay, so just because that would be bulky and unreadable for data types that are part of everyday life, such as or part of everyday programming, such as lists, and part of everyday life, such as numbers, they are hiding from you that you are calling constructor. Okay, so for example, with a string, we also used to seeing that this creates a string it's also hidden from you that what you're doing. So what is the data type, of this, of S, it's an object of type str. So the constructor should be str, and it is. You can do this today. This creates an object of type string that you can assign to variable S. Okay, so those things that you that so far we called converters, or we use them for, we thought of them as a function that convert from one type to another, such as int, you've used this, and str, you've used this, and even list, you use this. These are all constructors. You are calling a constructor. So when you're doing int and doing a for, or doing an in, something like this, Python is actually calling its constructor and say, construct an integer that looks like this. Okay, so these are all constructors. And at least when you are creating an object in an obvious way, it's hidden from you that you're calling constructor. By the way, remember how a point, we could have done this, right? At the beginning, you create an empty point. So there is so let me mention that actually this works. You know, you can just call a constructor, int constructor, to create an integer without giving any value. So what do you think is stored in X? What do you think is going to happen when I press X?
Nothing.
0.
0 is stored in X. So what Python does is that, remember, when you're creating your own date, when you're creating your own point, like an example, 0.23, that's because I want to create a specific point with values 2 and 3. But if I don't give any data for my point or for an integer, you can say, okay, in that case, I'm going to create an object of that type, but with default values. Somehow, if you don't tell me what you want, what point would you create? What would be a most common, or what would be a logical default integer? I think everybody would say 0. So that's exactly what this does. This constructor, in constructor, if you don't give it any values, it creates a 0. Okay, it creates a default integer, which is 0. What do you think it's a default string?
An empty string.
Sorry?
An empty string.
Exactly, it's an empty string, right? So you didn't give me any values, I'll give you an empty string. Default list is an empty list, and so on, right? The default float is going to be 0.0. So that's you as a programmer decide, what do you, first of all, do you want a default? Do you want to create an object if somebody doesn't give you any values? And if you do, you as a programmer decide what you think is a reasonable default object. Okay, what are the reasonable default values? Okay, so if the person doesn't give you points, so what I would like, for example, that if we do this with our point thing, that it creates some default point. Right now it crashes because, remember, what this does, it calls this function, but this function expects 2 values. So it crashes, telling you, I need 2 values. I need 2 arguments for X coord and Y coord. Okay, so let's say I want to create, I want this actually to work and create a default point. All right, but first question first, if somebody doesn't give you values, what point would you create?
0, 0.
Exactly. You create like a center of the coordinate system, and here you how you do it. You simply go to the parameters, and you can do this for any function, not just these ones in inside of a classes. So what you do, you go to this any parameter, you can assign it default value. You assign it straight in the header of the function. I say if the user doesn't give me x coord, then give it 0. And if it doesn't give me Y coord, you give it 0 yourself. So let's see now what happens. Do we get a crash when we create this point? So I say point Q is equal to this, and Q.x is 0, Q.y is 0. So what Python does is, of course, you have a call to constructor. So basically, it's a init function. It's looking for the first argument to assign to xcord. It's not there. So it falls back to the default value, which is 0. It looks for the second. It's not there. It falls back to the default value, which is 0. When you do, let's see that the old thing worked. P is equal point. Let me use something else. 1, 1. Okay, so P dot x is 1. P dot y is 1. So Python runs init function, looks for first argument, it finds it, assigns it to, well, fake first parameter, which is, so xcord is assigned 1, finds another value, it's 1, and it's assigned it to the next parameter, which is ycord. So xcord and ycord are 1 in that case. What do you think happens here? So let's create another point. R is point 7.11. Okay, this creates some point. What point does it create?
May I? I think it's going to create 7.11 for x and 0 for y. That's
right. So basically it just follows this formula. It looks for the, so basically self is R, our point. It looks for the next argument 7.11, assigns to next parameter, which is xcord. So xcord becomes 7.11. And then it looks for the next argument. It's not there. So it falls back to default one and assigns y to the default one. So the point becomes our point x and our point y. The point becomes 7.11. So actually, this is the first time you see how to design a function where you can send it where the number of arguments you send it appears to be less than the number of parameters, right? So here we have 3, or if you, let's say 3 parameters, but you can make a call with 0, 1, or 2 values, okay? All right, so let me make sure that I didn't skip anything. Okay, so before I continue with what I want to cover here, let me just also mention that there is a question that I often get, and which is, what's the difference in terminology? What's the difference between a class and an object? Okay. Class is just a recipe. This is just a recipe of how you should make an object should somebody call it, should somebody try to create an object of that type. So class is a dead code until somebody calls it or try to make an object of that type. And in that case, when somebody tries to make an object of that type, then this code becomes live and starts running init function. So in that way, it's really like a function. Def, when you start this def and then a function name, this is a dead call until you have a function call. Okay, yes, Otman.
I was just wondering, does Python crash if you have a class and a function that have the same name, but they're different?
Why don't you try that? Or we can try this at the end of the class. I just want to cover something. There's a material that I would like to cover before the end.
Sure, I'll try it. Thanks.
No problem. Okay, so let's continue. This is the main thing. And now you ask yourself, what else would you like my class to have? So let's look at what we had in Turtle Graphics. We had, okay, once you create this object Alex, what can you do with it? You can move it forward. So you have an object Alex and you have this method, we call it with a dot operator function that moves a point forward. Then we have a function that moves it left. Then we have a function that calls, that changes its color. So you can decide for yourself what type of methods or what type of functions would you allow your object to have. So one of the first things, I guess, that you can do with a point, it's, let's say, move it, just like in Turtle Graphics. I start with some location, at some point, I want to move it somewhere else. So see how we were using it in, so far you were using object, we were not designing our own object. So let's see how we were using these methods, right? These are the functions that you were calling with a dot operator. So how we were using them is that you take an object, so a variable that takes you to some object, and then you make a function call. So we're going to now first time learn how you design that type of function, because so far all the functions that we were designing with a def, we start with a def, And when you have a function call, when you want to use it, you have to start with the function name. Your own functions, you were always calling them by starting with the function name. And here you're starting with the object, and then you have a dot operator, then you add the function name. The way to achieve it is you just put that function inside of the class, okay? This becomes a method. You're going to be calling it in an object-oriented way. So let me define my own now function. I now get to decide what it's called. Let me call it move. And what do I want to move? In order to move, you ask yourself, in order to decide, should I be putting this special parameter that is going to give me access to an object? You ask yourself, do I need an object? Well, I need to know which object you want to move. Imagine I created 2 points, P and Q, 100, 100. So if I need to know which one of them I should be moving. So whenever you need to know the object you're working with, you're going to need that variable that stores the address of the object. So by convention, we call it self. Okay. And then it's your own stuff that what does your function need? So if I want to move a point to a new location, there's various ways to do it. You can say, I'm just going to specify new X and Y coordinate. That's one way to do it. Another way that perhaps looks more like moving is that I'm going to specify, if I start at P, I really want to move it, not just jump. If I start at P, I want to specify by how much you move. So you can say move in X direction by 5 and in Y direction by 10, and that's how you move to a new location. So I get how much you move in X direction, how much you move in Y direction. If that's how I want to implement my move, I need 2 pieces of data, which is dx. You can think of it as different in X, so delta X, dy, and you need 2 pieces of data to tell me how much you want to move in X direction, how much you move in Y direction. And then I need, so self.x gives me a current X coordinate of that object, and I want to change it to dx by adding dx. Move, add dx in X direction, so that becomes my new, that becomes that object's new X coordinate, and we get the same for the Y coordinates. So let's run it and see if it works. So actually this already created. So we have this point P.X, P.Y. We have that point. Let's try to move it. P move. Want to move X by 100 and Y by 200 units. And let's see, P.X should now be, if I move it by 100, it should be 102, and P.Y should be 203. And indeed, that's because I put X here. Should be Y. I'm changing Y by that much. So let's run this again. Let's move P, and now P.X should be 2 plus 100 is 102. P.Y is, how did I do this?
You have
still have dx on the second line instead of dy.
Right, what?
Self
On the
y.
second
the
line.
last
Here,
one.
yes.
UI.
See, that's a danger of copy pasting thing. Anyways, so yes. So that's the danger of copy pasting and rushing. P.X, P.Y, finally. All right, so you see, so let's see what happens here. Again, it appears we have 3 parameters and we're only sending 2 values, but no. Look at what's in front of move. It's P. Here we have actually 2 points, P and Q. So P.X and Q.X, we have 2 points. By saying P.move, let's do another 2030, move again, 2300. What we're doing here, we are in fact sending 3 values. We are sending which point P gets assigned to self, and then 20 gets assigned to our next parameter, which is dx, and 300 gets assigned to dy. So here it's even much more obvious that the self is not some magic. It's just the first parameter where object P, address of object P gets assigned to it. And then so it's as usual, this is your argument, this is your argument, this is your argument. So this is your value, this is your value, this is your value. So there are 3 values and 3 parameters. Okay. All right. And in fact, to really show you that this is not some magic, this type of call, this is your classical code, is just hidden because this object-oriented way, this is an object-oriented style of calling functions. But in fact, so now it's we have yet another point. Doesn't matter. Let me look at Q, because Q we didn't touch. But in fact, what actually, even though you put this, what actually Python calls, you can think of it as making a classical function call. What do I call a classical function call? The one that starts with move. Okay, starts with a function name. Then you tell me, what do you want to move? I need what is self? Self is going to be P, the point I'm moving. Dx is going to be 20, and this is going to be 300. But in addition, I just have to tell Python, where is this move function? Where is it? Like, since I'm calling it like this, I need to tell Python where it is. So in the class point, call the move function and send these 2 pieces of data. Python actually runs this. So this is the classical call. P.x now changed. It's even more than it was before. You see it was increased by 20 and P.y increased by whatever, 300. So it's now like this. So this call and this call are exactly the same. It's just this is a style, object-oriented style. And if you want to do it like that, you put it inside of the class. All right, so and the last thing I want to show you for today, something that I really thought was super cool. First time, I'm gonna, Lila, keep your questions until the end. I have about 8 more minutes that I want to explain the last thing. So remember your questions and let's go over them at the end of the class. Let me show you something. Remember in Python, if you do something like today equal, no, let's do it like this even, so it's more obvious. S1 is today, S2 is today. If I do is S1 equal to S2, you get true. So in other words, in Python, it compares, so what is stored in S1 and S2, as always, are addresses of these objects, of these 2 strings. So these are 2 different objects. They have the same values, they have the same letters, but 2 objects are created in the memory, and S1 refers to one, S2 refers to others. And Python, although different addresses are stored in S1 and S2, Python thinks most people don't want to compare addresses. They want, when you do equal, they're asking, are these 2 variables, do they have the same values? Are they referring to 2 objects they have the same values? Okay, so that's what Python does. It does the same for the lists. You can do L1 is equal to 1, 2, 3. L2 is equal to 1, 2, 3, and you L1 equal L2. You're gonna get true. Okay. By the way, this is not the case in other languages. So this may be so obvious that that's what it should do. For those who are new, for who the first language is Python, but other languages don't do this. In Java, you're going to see next semester, when you create 2 lists or 2 arrays, if you do L1 equal L2, it's going to tell you false here, because it's comparing what is stored in variable L1 and variable L2, and these are addresses, okay? And these are addresses object, and these are not the 2 same objects. They just happen to have the same values. In Python, you can find, you can ask the same thing, L1 and L2, the same object, you just use an operator is. You're asking, is L1 in fact L2? Are these the same object? And it tells you false, these are not the same objects. So let's see what happens with our own data type, okay? So if I create a point, P, 3, and point Q, 2, 3, and I ask, is P equal to Q? Well, I would like it to say true, but it says false. That's because in my own custom-made data type, Python doesn't know what I consider to be the same object of my type. I have to tell it. And because I didn't tell it, I didn't code it myself, it falls back to the default behavior, and the default behavior is that you compare addresses, you compare whatever is stored in these two variables, and what is stored in these two variables are addresses of two objects. One is this object and the other one is this object. So what it does is de facto P is Q instead of comparing the content of this object. So if you want to change this behavior, you can, but you have to again use a function with a special name. By the way, remember when we did something like, if you want to know what are the functions and stuff available in math module, let me first import math or even list. I don't have to import. If I want to do dir list, Python tells me what's available. I can insert, I can pop, I can remove. And they were these underscore things that we so far didn't know what they are. Right now, at least for one of them, you know what it is. Here it is, an init function. There is a constructor. So when you do list, or when you do this, you create a list, it's actually calling this init function. All right, so let's see what my objects of type point, what do they have so far? Is it only init and move that they have? So if I do this, oh, it looks like my class has more stuff than what I just coded. Move is here. I coded move myself. Before I coded this, it wouldn't have been there. And init is there. But there are other things there. And the one, if you want to change the behavior, if you want to decide yourself when you consider two objects to, when do you want equal to return true or false, you have to code it yourself. And the function that you have to call, you have to use this name, underscore EQ underscore. So let's do that ourselves. So definition is underscore EQ underscore. Okay, so then you ask yourself, what do I need to give to this function? So let's see what we're doing when we are comparing two things. Okay, so I'm comparing P and Q. Okay, so P is an object of type point, Q is an object of type point. So if I want this function to be called when I'm doing this, I need to give it two pieces of information. I need to give it two objects that I'm comparing. Okay, so this function should have two parameters that take two objects of type point that I'm comparing. You can give them names, self and other. If that's too confusing, you can really rename it. Let me keep it P1. Let me call it P1 for point 1 and P2 for point 2. By the way, I failed to do it in this class. What is a type contract here? So I'm going to leave this one here empty. X chord is a float. Y chord is a float. What is the return type of this function, of init function?
None.
It's none. There is no, look for word return. There is no return. If there is no return, the function returns none. Okay, what about this? Self is the object of type what?
Address?
Point.
Well, all of them, I mean, look at this. When you do X is equal to 10, actually address of 10 is stored in X, right? But X is pointing to an object of type int. Okay.
Is it point?
It's a point, right? So address of object of type point is stored in self. So data type that self is referring to is a point. So here for the equal, I'm comparing two objects. I want to do is P equal Q. I'm comparing two objects of type point. So the type contract P1 is a point, P2 is a point, and I'm going to return Boolean to tell you, are these 2 points the same? So you decide when are the 2 points the same. In this case, seems obvious, but maybe it wouldn't be so obvious if my point, if I had a third data with my point. Let's say my point has a color, okay, and let's say default is black. So I have here self dot color is equal, or C, well, let's say color is equal to color. These are not the same. This is a variable that belongs to self, and this is my parameter here. Okay, so then you as a programmer decide when are the 2 points the same for me? Do they need to have only the coordinates that are the same, or the color has to also be the same for them to be considered the same. So let's say here I create a point 2, 3, and this one is red, and 2, 3, and this one is also red. No, let's say this one is black. Okay, so you as a programmer decide when do you consider two objects to be the same. Let's say for me, or whatever application I'm working with, I'm going to say that they are the same if I only need that the coordinates are the same. So if P1, remember, is the one point, the let's say point on the left-hand side. So if P1.x equal P2.x and P1.y equal P2.y, that's when I consider the points to be the same. So I want to return true. Otherwise, I want to return false. I hope by now all of you see that this if statement is completely unnecessary. I just want to return true or false. So I can just do this. I evaluate this expression. So if both x coordinates are the same and y coordinate the same, I want to return true. Otherwise, I want to return false. So let's see what happens now. Okay, so this created a point P where x coordinate is x, y coordinate is, x coordinate is 2, y coordinate is 3, and color is red. And the Q point has x coordinate 2, y 3, and color black. And when I do P equal Q, I'm not going to get false this time, I'm going to get true, because what gets run is this. So how does Python determine this? Let me explain that. So basically Python looks at the left-hand side of equal and sees an object of type point. It goes to the right-hand side of equal, sees an object of type point. And then in between them sees an equal operator. That means because both of these objects are type point, it goes to the point class and looks if you coded your own underscore EQ function underscore. If you did, it runs it. Okay, so how does it run it? So it sends P, the first variable here is P to P1 and Q to Q1. So this is P, this is Q, and it runs this function. In fact, I can demonstrate to you that it runs this function. Remember what I was showing you for the move function? You can call it in classical way, underscore EQ underscore. Then you do, I want to send P for P1, I want to send Q for P2. And where is this function? It's in class point, and there you go, it runs it. And that's in fact what happens when you do this, when you use equal for every data type that you've seen so far. When you do 3 equal 4 or whatever, 3, Python goes left-hand side, this is an integer, right-hand side, this is an integer, it goes to an int class, checks there, did somebody coded this function, and somebody did, and then it runs that function. In fact, I can demonstrate that it does. This is just a nice way. Who wants to write this? I mean, nobody wants to write this. Everybody wants to write that. But when you write something like this, 3 equal to 4, what Python actually writes, it goes to int class, runs in underscore EQ underscore for int on these two integers. So this happens, it's the same with when you are comparing two lists. So 2, 3 equal, let's not put something that is not the same, 300, 2, what Python runs actually, these are two lists, so it goes to a list class, finds two objects of type list, goes there, checks, is there this function in list class? It is, so it runs it, and it compares this list to this list and tells us that they are not the same. And I missed something here. Oh yeah, square bracket. Okay, so now you know what this does. This equal is not some magic, it's just a function call to special function. Okay, so I'm going to stop at this time. Those who have questions, you can ask them. I think Maid had a question hand up from a while back. Maid.
I just wanted to ask, what is the point of self? But then I understood it.
Okay,
But like, can you clarify a little bit? Why do we put self?
it doesn't have to be self. It can be.
No, yeah. Why do we put anything?
Because you need to know. Let's look at here. In a Python visualizer. Okay, so you're creating this object on the right-hand side, and indeed you can create without, let's say this one here. So the first object when we were creating it. You're going to create an object there, and indeed you can imagine somewhere in the memory I can have a variable x and y be assigned value 2 and 3. But what you want now, you want this whole object, you want an address of this object. Okay, so you want address of this object, so that variable p, so you want variable p to have address of this object. Okay?
Okay.
So it's that address of the object that you're just creating that is assigned to self.
Oh, okay.
So it's just the, and even more so in Python, if I just did x is equal to 2, remember what would have happened. Let me do this here. Let me actually do it. Edit code. Let me do this. X is equal, let's do this. Let's see that you're going to see the difference. Y is equal to x squared. Okay, visualize. All right, next, everything is as before. This function starts running. Let's see what happens. If you just do this, this is x on the left-hand side. You want this variable x to belong to an object, right? Because you create, each object should have its own variable x and y. But if you do something like this, you just put x on the left-hand side and y on the left-hand side. But these are just variable, instance variable of a function. They're going to be created here in the function. You don't want x and y to belong to a function. You want x and y to belong to an object. The object you just created. So let's execute this. You're going to see what happens. I'm going to now execute line 4. You see on the left-hand side, x, variable x will be created, and x squared is 2 is going to be assigned. That's not what we wanted. Variable y is just created and 2 is assigned to it. What I wanted is to create this object that I just created. I want this object to have variable x and y. To do that, I need an address of the object that I just created, and that address is stored in self. I want address, so I want to go over here, and to this thing over here, I want to give it variable x and y. So see what happens now when I do x, self.x. So follow where x is, follow self, where you created an empty object. It's going to take me to that address. So what's stored in self is empty object of type point that is just created. I follow it and create a variable x there. So I create an object. So my object self that I just created just got a variable x. And now it just got a variable 2. So let's see what happened with just those x and y. They're going to disappear. But this object stays and its address is assigned here to p.